Okay guys, so in the last few lectures I think we covered upon ring expansion. So in this lecture we'll be taking on that concept forward, and we'll be taking on a new article called Dienone Phenole rearrangement. Okay, so let me put down the heading first. Dienone Phenole rearrangement. Okay, so suppose we have a product something like this, uh, sorry, a substrate something like this, and double bond here, and we have this here. What will happen when we place this in acidic medium and heat it? First, dienone means from the ketone form, enol form will take place. The formation of enol form will take place, and we'll have something like this. That OH double bond comes to here, and we get a positive charge here, and two CH3 here. Then what will happen is CH3 minus shift will happen, which will actually make our intermediate something similar to this, and positive charge actually comes over here and OH here. Again HSO4, next step would be obvious. This alpha hydrogen will be taken away by HSO4, creating a phenol and with two substituents. Okay, so this is the example of dienone phenol rearrangement. Okay, second example is we have something like this, double bond O here, we have a CS3 group over here, again acidic medium, and we heat it. What will happen is first this keto will convert into enol form. We'll have something like this, and this and positive charge comes here, and we have CS3 over here. Okay, so now what actually happens is so this is one of the ways in which enol can be formed, and second way can be something like this, in which this actually comes here, and we get something like this, and we get a positive charge here and a CS3 obviously at this position. From this CS3 minus shift will take place. And why will CS3 minus shift will take place? Because if we have something like this is more having more number of alpha hydrogen. Okay, CS3 here, and again from this H plus, from this HSO4 will take away the alpha hydrogen, and we'll get phenol here and OH and CH3 here. Oh sorry. And what happened in this case is alpha hydrogen is not present in this case because 4 valencies of carbon are satisfied with going into these 4 directions and one on CH3. So we'll get a alpha hydrogen here from here, but this will be a minor product in which we'll have a double bond somewhat like here, but this would be a minor product, and the major product would be this in this case, because of the formation of benzene like compound which is aromatic. Okay, this ring becomes a benzene like structure. Okay, now I hope in the previous set of organic chemistry lectures we talked about what is called Darzen process, but we didn't talk about mechanism of the Darzen process. So here we are going to talk about the mechanism of Darzen process. Mechanism Darzen process. Okay, so what actually happens when we react this compound and OH with SOCl2, we have ClCl and double bond over here. So S will have a partial positive charge. So what will happen is this O will actually attack on this sulfur atom to form something like positive charge here, H atom here, S, and this actually bond will be taken away, these pi electrons will be taken away by oxygen atom to form something like this. Okay, so now what will happen is we actually did this in presence of pyridine. So now what will happen is we have this pyridine which is a good base. Okay, so what will happen is this lone pair will attract this hydrogen atom. So now what will happen is we will have something like this, in which I have pH here, H, CH3, O, SO, and what actually happens is this O minus will again form a bond with sulfur, and chlorine will be detached, and we'll have something like this. This N atom would have gotten a positive charge because of attracting H plus. Okay, so now what will happen is this oxygen atom will detach from this carbon atom. The bond electrons will be taken back by oxygen atom, and at the same time this chlorine will attack it from the back end side. Okay, so now what will happen is better this chlorine can attack. Okay, and this chlorine can be removed. Okay, so the formation of SO2 gas and Cl minus will again happen in the reaction, and this chlorine would actually attack as a nucleophile from the back end side, as what we seen in the SN2 reaction. Okay, hence inversion of the configuration of the reactant or the substrate takes place. Okay, and we'll get something like this as our major product. Okay, this was the case 1 of the Darzen process. Now let's see what happens if we don't have a presence of pyridine. So let's now talk about case 2, where we have something like this, in which I have and I react this with SOCl2. So let's talk from the intermediate process only. So we had something like this as the intermediate process, and we don't have the presence of pyridine. So next what will happen is this O will be taking back its bond electrons from carbon atom, and at the same time this Cl will attack on the same carbon atom. Okay, so in this case, plus HSO2 would be released, and we'll have Cl, PH and CS3 here. Okay, so in this case, retention of the configuration takes place in the product. Okay, so we talked about two cases in which of the Darzen mechanism, in which in the first case SN2 reaction takes place, in which the inversion of the configuration of the substrate takes place because of the presence of pyridine. Why? Because the pyridine attacks the hydrogen atom, and the released chlorine atom from the previous step actually attacks from the back side of the carbon atom, allowing the SO2 gas to be released from the front side. Okay, but in the second case, retention of the configuration takes place because there is no pyridine, hence the OH, in which O has a positive charge, has to break its bond from the carbon atom, and at the same time the chlorine from the same compound actually liberates itself and attacks on the carbon atom at the same time, hence retention of the configuration happens, and with the formation of this product. Okay, so with this we come to an end of this lecture. In the next lecture we'll be talking about cascade rearrangement. Till then, good luck and goodbye.